Welcome back, Math 2. Today we are going to start working with our polynomials, and today we're going to learn how to add and subtract two separate polynomials, okay? So let's talk about first, like, what can actually add and subtract. So we are going to refer to this phrase like terms. So like terms in a polynomial have to have the same variable and exponent. Okay, so for example, 3x to the fifth and negative 5, no, not 5, I don't want to use 5, and negative 4x to the fifth are like terms because they both have an x and they both have an exponent of 5, but 2x and 9x squared are not like terms because this has an exponent of 2 and this does not. Okay, so let's just go ahead and practice an example because most of this is really just going to be about adding and subtracting terms that are like, that can actually combine. Okay, so here is, my first example. I have a binomial, 2x plus 5, plus a trinomial, 3x squared minus 7x plus 8. And all I'm really going to do when I add these is combine my like terms. So I'm going to start with, I'm just going to go in order. I have a 2x over here, and I have a negative 7x over here. Those both have the same variable and exponent, so they can combine. 2 minus 7 makes negative 5x. And then the next thing I have is a 5, which can combine with this 8 over here. So 5 plus 8 makes a positive 13. So now that I've used everything that can combine, I do still have this 3x squared left over, and I do still need to include it. It just won't change. It'll stay as it is. Now, the last thing, remember, is that we talked about standard form. So I need to rewrite this answer so that it's in standard form. And really all that's going to mean is that that 3x squared should be at the front because everything else was already in standard form. So that is my answer. Okay. Let's try another one. Okay. So negative 7x to the fifth plus 14 minus 2x, that's one trinomial, plus 10x to the fourth plus 7x plus 5x to the fifth. Okay, that's another trinomial. I'm just going to start over here on the left. It doesn't really matter where you start as long as you make sure you combine everything and include anything that couldn't be combined. Okay. I have a negative 7x to the fifth, so I need something else with an x to the fifth, which would be this 5x to the fifth over here. Negative 7 plus 5 makes negative 2x to the fifth. So I'm done with those. If you want to cross them out after you're done with them, that's not a bad idea. Then I have a 14. So that is a plain constant number. And there actually are no other plain constant numbers in my second trinomial. So I'm just going to include that. It's not going to change. Then I have a negative 2x, which can combine with this 7x over here, making 5x, and it's positive, so I'll make sure I use a plus sign. And then I have this leftover 10x to the fourth. Okay. So everything is combined. I don't see any of the same exponent that I can still combine, but I do want to make sure my answer is in standard form. So I'm going to start with that negative 2x to the fifth. The next lowest exponent is 10x to the fourth. Then I have 5x, and all of this is positive, so that's nice. And then I end with 14. Okay. So that is adding. So the reason we call that specifically adding polynomials is because in between the two parentheses was a plus sign. Okay. Now we're going to talk about subtracting. Okay. Subtracting is going to look very similar. The only difference is that, if I can get it to move, is that before I subtract, I need to distribute my negative. So let's write that down as our subtracting step here. So we are going to distribute the subtraction sign to make it an addition problem. Okay. Give you a second to write those examples down. But while you're writing them down, let me kind of explain why. Okay, so if I were to just look at this first problem, 2x plus 5 as a polynomial minus the polynomial 3x squared minus 7x plus 8. When I go to combine the 2x and the negative 7x, I have to remember that I'm subtracting. So it'd really be like 2x minus negative 7x. And that can be really hard to remember to do. So the best thing to do, which is what I'm going to do here, I'm going to take this negative and pretend it's a negative 1, and I'm going to distribute it inside. Okay. And what that's going to do is it will turn that minus sign into a plus sign, and then everything inside the parenthesis will switch whether it was positive or negative. So now I have a negative 3x squared, a positive 7x, and a negative 8. So now when I go to combine, I don't have to think, oh, I'm subtracting a negative, or I'm adding a minus, or I'm subtracting a positive. It's less complicated than that. Now I can just go ahead and combine like terms like I normally do. So when I combine 2x and positive 7x, I didn't have to think minus negative. I can just say plus. So 2x plus 7x makes 9x. 5 minus 8, so I don't have to think about the fact that I'm subtracting a positive. 5 minus 8 is negative 3. And then the other big thing that this really helps with are those numbers that aren't going to combine. Okay, because even though I don't combine my 3x squared with anything else, it was also still being subtracted, so it now has to become negative. Okay. And again, I'm going to rewrite this answer in standard form. So I'm going to put negative 3x squared plus 9x minus 3. Let's do one more example. So I'm going to take my negative and I'm only distributing to the right because that's where the negative is multiplied by. So now it will be plus negative h to the fourth, positive 7h to the third, positive 3. Okay. When I go to combine, I'm just going to start on the left here. I have 8h to the third and a positive 7h to the third. That makes 15h to the third. Negative 6 plus 3 is negative 3. And then I have a 3h to the fourth and a negative h to the fourth, which makes 2h to the fourth. And then again, I'm just going to rearrange this. So that it is in standard form.